Hi, everybody. Thanks for joining our webinar. I think we are just going to hold on for about 1 minute for those who are patiently waiting. Thank you so much. We're just going to see if we can see who might come in the next minute or so before we get started. Just be a few minutes. All right, guys, I think we'll go ahead and get started now. Thank you so much for attending our webinar today. So obviously this is the GIS for AgTech webinar, and today we're going to be kind of talking to you guys about how New Zealand organizations are using ArcGIS to make agriculture more productive, more sustainable, and safer. So with that, I think we will go ahead and get started. So first things first, introductions. So my name is Jess Houston. I am filling in today for Scott Campbell. He was the original presentation presenter for this webinar. Unfortunately, he's been called away for other business. I am a technical solutions engineer for Eagle Technology, which means that I have experience with exploring demonstrations of different tech and coming up with custom solutions for a variety of industries. And I'm based in the Wellington office, and then we also have Sarah here. I'll let you introduce yourself.
Hi everyone, yeah, my name is Sarah Pitcher-Campbell and I'm based in Rotorua, and I'm the GIS account manager for agribusiness and forestry. So anyone who's using GIS within those industries, I'm generally working with on their use and development of geospatial technology.
Awesome, thank you for that, Sarah. Just an overview of what we're going to kind of be talking about today. Obviously, we have a couple different topics. We'll start with doing a real quick just background and then maybe technology overview. But then we'll get right into it with GIS and open data, have some demonstrations of that. We'll have some really cool customer stories and with the examples of actual customers using technology in the agriculture field. We'll then just leave you guys with a couple of resources, talk about future webinars coming up, and we'll have opportunities for a live Q&A. For those of you who may not have attended a webinar in the past, just a little brief tech information about how a webinar works is that you should find a question panel on the right-hand side of your screen. Feel free to ask questions at any time throughout the webinar, and we'll do our best to address these at the very end. And if we don't get to them, we can get your contact information through that panel as well and follow up afterwards. So like I said before, we're just going to start off with a very, very brief technology overview. I'm sure that a lot of people attending today are probably very familiar with GIS, but just in case and just to kind of warm up, GIS is just about integrating different sources of information from traditional maps and data, but then making it available for a variety of purposes. This lets us model our real world in a digital way, whether it's built environments, your buildings, streets, assets, or maybe the natural environment, which I'm sure is very relevant to most of you guys here today, with in regards to your water systems, catchments, weather, etc. Where our GIS comes in is that we're bringing an advancement over older traditional GIS data to bring in basically any type of spatial data. We're not just limited to shape files anymore. We can do real-time data, LiDAR, 3D modeling, and more. ArcGIS allows us to bring that data in a meaningful and very easy way. Another thing to keep in mind of increasing importance is this concept that ArcGIS is an enterprise system. It's not being used just by specific GIS teams anymore. It has to be considered an enterprise system from an IT perspective, which means it needs to be reliable, scalable, able to integrate, and it needs to be available to people in lots of different types of roles. In regards to the agriculture sector, this means that in your roles where your specific concerns are going to be farm mapping, farm safety, compliance, productivity, the information is the same and still accessible to you. Content is probably going to be the core heart of GIS, and as a community, we've kind of moved into this new realm of authoritative, cloud-based or enterprise-based repository of geospatial information, which is really the way forward. And this means that we're going to be able to bring in data sets into our ArcGIS system automatically, easy, from layers like biodiversity or land cover, or even if it's just as simple as a wide-ranging selection of base maps. So we are going to talk about briefly just open data in general and how useful that is for you guys in the agriculture field. And with that, I'll pass it quickly over to Sarah.
Cool, thanks Jess. So yeah, there is an increasing demand for spatial data in a range of industries, including farming, but there's also an increased availability of open spatial data. In fact, there's a wealth of information available out there, and so most of the things that Jess and I will discuss, whether or not it's the use cases and the demonstrations, they all kind of incorporate the use of open data. From an agriculture perspective, demand drivers for the spatial data come from a variety of sources, including regulation and compliance, such as farm environmental plans, freshwater farm plans, which seems to be the new cab off the rank, so to speak. Spray plans, you know, they all have a spatial or map component to them and use information and data which can best be collected, accessed and understood spatially. So we can look to combine, you know, what open data is available out there and combine that with more farm specific data for infrastructure mapping, precision ag, asset mapping, such as, you know, underground or overhead power lines, and of course a most recent illustration of open data is around disaster response, such as following Cyclone Gabrielle, and we can think about how critical post-cyclone imagery is and is still being used, and having that both captured and in a timely manner, but having it open to everyone to consume for recovery purposes. And so where is this data coming from? It comes from a range of sources. Probably one of the biggest is regional councils. Even when we think of, say, our New Zealand aerial base map, you know, that is aerial imagery that is originally captured or acquired by regional councils, and you know, regional council their web mapping portals and all things like that is all open data that we can consume inside our GIS and specifically ArcGIS platforms, along with other public data GIS sites. You know, there's Landcare, LINS, Coordinates, all those type of places where we can either get data directly as a web service or even download and manage and consume inside our own systems. And then of course we have GARDA, or the Geospatial Aotearoa Data Audit, and Jess will go into a bit more around data via GARDA as well. So if we just dig in or do a little slightly deeper dive into one of those use cases, and I've picked freshwater farm plans, and you know, we don't really know a lot about these at the moment, but we know they're designed to give good environmental outcomes for farmers through reducing farm impact on freshwater. And regulations are expected to roll out, sometime later this year, mid to later this year. But we know spatial data will provide a key role in developing those plans. Specifically, when we're looking at identifying and mapping and describing land units, which is around the physical characteristic of the land, not a management unit. So, when we think about that physical characteristic of the land, it's the soil, it's the slope, where irrigation is applied and where drainage occurs, which of course are all very spatial, along with inherent risks to each of those land units, including via catchment content. So, where would erosion look to occur? Do we have shallow water tables? What areas are close to water bodies? And from there we can overlay or bring in our farming and growing activities of what is being done and where. So that is bringing in more the farm data, effluent spreading, point sources, where we look to do our intensive winter grazing. So all that basically has a spatial feel. And when we look at slope, soil, drainage, all that information, a lot of that can be sourced via open data platforms. So with that, I'll hand it back to Jess just to demonstrate some open data.
Thank you for that, Sarah. Yes, I'm going to go into just a real quick demo, basically, just talking about some of those data layers that would be of use to you that Sarah had mentioned before. And what I've done for you today is I've just pulled together a web map to kind of show how easy and accessible all these data layers can be for you. So looking at the screen now, I am open in a map viewer in my ArcGIS Online account. And this map you see here is a combination of several things. It's a combination of that program that Sarah mentioned before called GATA, in which we are accumulating our own internal list of data sets that are going to be of use to you guys, that are publicly available, that would be organized based on categories of interest. Obviously, ag sector, for instance. This is a web map that we've been working on to just sort of accumulate and organize a little bit with what sort of authoritative data layers are going to be available for you guys. And so here in this web map here, I have many, many layers. This is kind of a Mapzilla in that it's probably quite a lot more than you need, but it's just nice to see all the things that are available to you. And starting with the number one thing that keeps coming up, what we heard from you guys, as in data layers that were requested in kind of the ag space, one of the ones that came up is obviously slope. And there are actually really easily accessible layers out there that you can plop into your map to get this sort of information, including this layer here, which is actually the World Terrain Service provided by Esri, which is a service for the entire world to create slope and to find your sort of elevation values. But the data that it's actually showing and collecting is local. So this service, even though it's set for the entire world, is on New Zealand right now. And this data, which is a map of slope, actually, if we click on the pop-up here, which might take a second to load, it's actually coming from LINS data. It's coming from that LiDAR data that they collected 2018, and it's 1 meter. It's actually very accurate, and it's hopefully very, very useful for you guys. And what I did here is, this is a fully usable and editable layer that you can kind of create for your own purposes. And that I had actually set a filter on this layer. And so you can add expressions if you want to kind of narrow down what kind of data it was. Maybe you need to reclassify your slope, so you can mess around with the symbology so that you're only seeing certain ranges of slope that you need in your area. But like this, I can narrow down to, I just wanted to make sure I'm only looking at the New Zealand ones, or the one that comes from specifically LINS 1 meter DEMs. Hopefully that's extremely useful for you guys to be able to export that as a separate layer and whatever symbology modifications that you want to make. Again, that's just one possible layer. There's so much out there that's available in the whole ArcGIS Online system. We have river catchments, Ministry of Environment has their own stock exclusion as well. And again, these are just publicly accessible data layers that you can pull into your maps and create products from there. And there's lots of different uses I can imagine you guys have for this sort of information. I won't go through all of it, but some of these catalogs, for instance, we have resource consents that were collected by CATA. And this is just showing lots of point data that had been publicly published by regional councils. So we collected all that for you guys so that it's easy to see where these sort of land permits are coming from. You can see here, there's a point data we're in Gisborne right now, taking a look at what is available here. There are district plan zones. We have some sites of cultural and natural significance as well. And this purple polygon here is just saying what's available. We also have river classification. So this is also a really awesome authoritative layer that is published by NIWA that is available for you. So just plug and plop into your maps again. And then LINS. LINS is, of course, one of our Esri curated authoritative sources from Living Atlas. And for those of you who may not be aware of what Living Atlas is, it's just a repository of the checked over, this is definitely authoritative, easy to grab, plug and plop into your map layers, and that we know are coming from a really solid source, essentially. And then I also just have geology here. This is a map that a map layer that actually Eagle Technology provides, which is again just the national database of some geology information. And this is by far not the limit of how much data is out there. This is just an example of the kind of cataloging and the availability of content that we have for you guys for use in all your maps. With that, I'm going to switch gears again. And next, I actually have not a live demo, but I did want to talk about one other thing that might be useful for you guys as a demonstration. And we're actually going to be talking about ArcGIS Pro. So this is just a sort of a tech tip for you guys. If anyone's familiar with using ArcGIS Pro, which is our 64-bit desktop software program, it has an extension called Spatial Analyst. And what this extension does is give you access to some really advanced spatial analysis capabilities. One thing that is probably familiar to quite a few of you guys with farm planning is critical source areas. For those that aren't aware, it's basically anywhere on a farm that's at a risk of losing contaminants. They're often called hotspots for contaminant loss. Basically areas where there's concerns of runoff accumulation. With ArcGIS Pro, we actually have recently some really fancy updates to a suite of hydrology tools. And what these are going to allow you to do is to get more information about how water is flowing throughout your farm. Starting off, step one basically is getting some of those high quality DEMs. So we mentioned LINS before. For those who aren't aware, LINS has an elevation program where they are taking LiDAR of the entire country. And they have lots of really high resolution. We have 1 meter here, DEM in Taranaki from, I believe it was flown in 2021. These are, again, really easily accessible to throw into a map. And with this information, you can then create flow accumulation. You can create flow direction. You can actually derive your own local streams to see where water will be flowing in your land. Obviously, flow across the surface is always going to be steepest downslope direction. And so these tools calculate that for you and help you to actually define where the water is going to be flowing. And then from there, you can even take it a step further. So you can actually create your own watersheds to see exactly the catchment of where water is going to go. With this, you can use your source locations of maybe you have a stream gauge somewhere, you have a dam, you have a location that you want to know where water is going to go from there. And so what these tools do is allow you to find the characteristics of this sort of water contributing area. With that, I'm going to pass it back to Sarah so we can have some New Zealand stories of ArcGIS in tech in the ag space.
Cool, thanks for that, Jess. Yeah, it's great to see some of the the data that is now available out there. So, gone are the days where we have to either acquire a lot of that data ourselves or do a lot of pre-processing on data. A lot of that can be done for us automatically now. So yeah, so the next part is running through some of you guys out there, some of the great work using GIS in the ag space that's been happening over the last year or so. So first up, we've got Fed Farmers. So Fed Farmers is a not-for-profit organisation funded through voluntary membership, and they're a designated support agency in animal welfare and provide direct support and coordination services to commercial livestock owners and assist in migrating animal suffering as a result of emergency. So the next couple of slides, we're going to take a look at how the team used GIS for response and recovery in the rural sector following Cyclone Gabrielle. So Fed Farmers used Survey 123 to collect information. Multiple surveys were stood up side by side during the response and recovery period to collect information across a range of issues. So there was a voluntary registration survey where people could sign up to volunteer, and they had nearly 720 volunteers register using the survey. Properties that needed cleanup, so people could request help, and there was 151 properties requested help for cleanup. These are all surveys that were put out via the web, so people could log on and fill surveys out online. Survey around where diggers, dozers and fences, 68 responses there with either needing help or availability to help out. And lastly, a feed coordination survey, so 465 submissions across 4 surveys. So basically connecting those who have feed or grazing to those that need it. So these surveys easily shared with the public, simple to access and submit, and the data, of course, is instantly available for the team for further analysis and mapping. And so that data that was collected in those surveys is then easily available to be mapped alongside with aerial imagery and, of course, other publicly available data from the event. So the team could understand what damage had been caused, where the response efforts should be focused, who needed resources, how they could support the rural communities, and why they're providing geospatial products, basically. So here's a dashboard showing that the team used internally, showing initial floods damage to members' lands. Basically taking that live feed from the survey. So as it's being filled out, the widgets and things like that automatically update. So very much, everyone loves a good dashboard. They're very visual and they really tell a story. Here, this is I think it's quite, provides quite an impact and really illustrates the devastation. It's just something as simple as a 3D representation of a farmer requesting help overlaid with some other imagery that was captured post-cyclone. So you can really providing, moving from even 2D into 3D helps really visualize the impacts, and kind of brings it home how bad the damage really is. And lastly, from the team is around, them using open data. So as I said earlier, like today's webinar is heavily focused around open data and its use in ag, and Fed Farmers use open data from the Hawke's Bay Regional Council as part of their flood response. So yeah, fantastic illustration of using GIS. Kind of following on from with the cyclone theme, Ravensdown launched Hawkeye Response, which is a software tool to help farmers map and deal with slips that have impacted their farm's effective areas, compromised paddocks or taken out paddocks, and users can identify erosion-prone areas to prepare for future weather events. So the new tool combines pre and post Cyclone Gabrielle satellite imagery with fixed wing aerial imagery, and it brings it into the existing Hawkeye software. So, in this this slide is, there's the standard swipe tool, being able to compare the pre and post with the map slips. So once in Hawkeye, images of slips and washouts are cross-references against existing fence line data, to give farmers an up-to-date spatial view of the damage on the property, even without getting out on farm. Here's just another illustration of that zoomed in. Not only have you got existing mapped areas, automatic slip detection, but they can actually map out additional areas that may suffer in the future. So, farmers can identify each paddock's new effective area and test new methods of farm and stock management virtually before committing to any changes. The software analysis and editing abilities help the farmer to help set up exclusion zones so that any areas of slips can be retargeted for reseeding, and further potential erosion-prone lands can be cordoned off for future reseeding or stock grazing. So really, that Hawkeye response tool gives farmers that pre and post Cyclone Gabrielle imagery with their own farm data, such as fence lines, identifies those slips, can calculate the areas of those slips, and then be able to produce the new effective farm area. Of course, we've got our standard editing tools such as measuring distance and area, and farmers can ring fence areas for future land uses, and of course download the data into spreadsheets that they can use for further analysis. The Delta Waterways team, we first met these guys at the field days late last year, and they are an award-winning startup who are pioneering the use of satellite imagery to understand more about the nature of our rivers. So they're a group of 3 students from the University of Auckland and Auckland University of Technology, and they competed in a hackathon back in 2021. And we're given 24 hours to solve a real-world problem. And so their problem was waterways, and Delta Waterways utilise satellite imagery to revolutionise the way we understand and monitor our waterways. The imagery, of course, allows significant spatial coverage that is really unachievable by current methods such as manual sampling or in situ sensors, allowing problems to be traced to their source, identify areas of concern, and be more proactive instead of reactive with water care efforts. The data can be delivered essentially in any form a user requires. In the example on our screen, we've got visualizing using dashboards, but it could also be in standard report formats, or even real-time alerts. And the information that can be provided can be anything that can be discerned from the satellite imagery. So right now the focus is on turbidity, but moving forward the team have plans for chlorophyll and eventually nitrates and phosphorus and phosphate, sorry. So GPSit, they are New Zealand's farm and orchard mapping experts and have extensive experience in developing GIS solutions across a variety of sectors, particularly in the ag and horticulture space. So in this example, we've got from them a grower wanted to see the effect of a proposed easement on their property. So the team, using ArcGIS Pro, loaded in the easement plan, of course, all the orchard data that was already mapped, and updated drone imagery, and then used spatial analysis to determine the impact on the property. This information was then served up via a web map and an instant app to create a simple app that the grower could then use to visualize the impact on the property. So it's an example of someone with technical ability using ArcGIS Pro, but providing the kind of like the end product back as a web app to the user. In this example, kind of follows on a little bit what Jess was showing with open data. We've got a combination of a terrain model. This could be highly likely from our high resolution LiDAR data, combined with drone imagery. Loading those two into ArcGIS Pro, the farm map can now be reprojected in 3D to give those better visualizations of where waterways are, where our low-lying areas are, where our high-sloped areas are. It's a great tool. And then here's a web application around spray drift and spray pans. So this is a spray drift data, or displaying spray drift data in a custom app built on the JavaScript API for ArcGIS. So we know that spray pans are needed for all commercial activities when using machines or aircrafts to apply agrochemicals within 50 meters of a boundary more than 2 times a year. So a plan helps to identify areas sensitive to spray and decide on methods that will minimize spray drift. So again, an orchard owner can see this information via a web app. In this example, it's a custom web app. And if we move to the next slide, we can see that we can see that here's just a similar data, but that 3D representation. So obviously the 3 areas where there's potential for spray drift, and you can appreciate that visualizing that in a 3D way as opposed to 2D certainly helps. So there's just a few examples of what the GIS community within the agriculture space are doing, and keen to hear what some of you others have been doing. If you've got any great user stories, please reach out, because we love to hear them.
Thank you very much for that, Sarah. Yeah, awesome. That was kind of an in-depth look at some of our most recent customer stories there. We do have, looks like we have a little bit extra time. I did want to, before we get into sort of questions, I did want to just mention that there are quite a bit of resources out there for those who are learning or interested in learning more about the specific technology that we kind of talked about today. So there's basically 4 categories of ways you can go about learning more. We have, of course, ArcGIS blogs. These are constantly coming out with the best tips and tricks of the trades, lots of user case stories, but also just what's new and what's coming out. Obviously, we have quite an in-depth ArcGIS documentation as well, which can give really detailed explanations of how things work in any of the tools that we mentioned here today. For those of you who have more of a programming background, there is the ArcGIS developers page as well, which has lots of handy guides and information about the ArcGIS API. And then there's also a series of YouTube videos. So a lot of the things that we talked about today, even ag specific industry videos, are all going to be on our Esri YouTube page if you have any interest in that. And we also actually have recordings of many of our events that we have, such as our webinars that we post, but we also actually have videos out there of things from like our regional conferences, from our user conference that happens once a year. And these are really hopefully helpful to you guys in that we have, again, customer use stories, but we also have examples and demonstrations of a lot of the new tech that's coming out that might be useful to you guys if you watch those videos. Upcoming webinars, we do have more. So the next one coming up is WebGIS interconnecting your organization, and that's coming up on May 18th. After that, you will see me again for the Migrating to ArcGIS Pro webinar on June 15th, and then finally on the 20th of July, what's new in local maps. You can find out more about any of these webinars coming up at eagle.co.nz.learn. Beyond that, we do have a amount of time for questions. I haven't seen anybody roll any questions into the presentation, which is totally okay. But again, it's just going to be in that panel on the right-hand side. This is a good opportunity if you guys have any questions about any of the user stories that we showed you today. If you had any questions about any of the data layers, perhaps, that I showed, and maybe where you could find those and how to access them or pull them into your own systems. Or any sort of questions about maybe like ArcGIS Pro, which I did show a brief demonstration of, though I didn't get super into details about that. If we're not pulling up any questions, that is okay. What I can use a bit of this time for is perhaps going a little bit more in depth on that web map that I showed earlier, which has all those data layers. So I think I will pull that up just because we have quite a bit of extra time here and kind of go a little bit of a deeper look in that. But please populate the question panel if there's anything specific that you'd like to talk about or have addressed here today. But in the meantime, I'm going to go ahead and pull up that big Mapzilla that I had before. So hopefully that's back on screen. There we go. I did just want to show what I mean about the slope layer as well and where that could come in handy for you guys. Obviously, I have quite a lot of data on this map here, which I can turn off so we're not completely overloaded. Again, catchments is something I also want to emphasize that as well. There's a lot of catchment data that's available publicly. I showed in ArcGIS Pro how to make your own, how to make subcatchments more localized to your map. However, there is large catchment data that's already been created by other users in ArcGIS Online that you have access to, including NIWA and other authoritative sources as well. I did just have a question actually coming in that's really relevant actually to this web map, which is fantastic. I just had a question. Where do you find New Zealand Living Atlas? Obviously, a lot of these layers, oh, sorry, no, what do you find if it's not in Living Atlas? Gotcha. So a lot of these layers did come from Living Atlas, which for those who aren't familiar, we have in our ArcGIS Online web account here this ability to add layers, browse layers. I can go to My Contents or Living Atlas. And this is where you find the repository of everything here. You can search. Obviously, I searched for train slope map, which was Living Atlas layer. However, what if it's not in Living Atlas? That's a great question because a lot of the publicly accessible layers out there aren't going to be in an easy to find location like this, which was the premise of why we wanted to get GATA started, because we wanted some sort of repository to make it a lot easier for you guys to find these layers that are out there. They exist, you can use them easily, but it's just really hard to shift through Google and try to find that. One thing that we would like to recommend though that in GATA that we've been doing is Regional Council Open Portals. That's the #1 source of really authoritative data that's quite local. a lot of data is accumulating this sort of information. For instance, the sites of cultural and natural significance. So this is not a living atlas. This is something that we pulled together. And essentially what this is, I go to this layer. And I'm going to pull out a little bit so we can see more of what's going on. And I'm going to turn off our catchments. And I'm also going to turn off lens data. So here, basically what this layer is, but it does seem to be having a little bit of trouble loading. Let's go ahead and pull that up. There we go. So we basically, what we're seeing here are the regions that regional councils did actually publish publicly available layers. With these layers, we basically attached all the service URLs because you can go to these portals and you can download them as CSVs, shapefiles directly from these websites. But what you can also do is you can add them either from the URL, which is very easy, or you can actually search through ArcGIS Online and find that information as well. Because most of these regional councils, if they're putting it on their ArcGIS web portal, that means that it's actually going to be available through ArcGIS Online directly, and so you can search it in your map and then add it. I think we are getting a couple more questions here. I have one question: if there is a list of geospatial apps or solutions for New Zealand's agri sector to ensure that there's no duplication with resources being developed. That's a great question. As pre-existing geospatial apps or solutions, Sarah, do you happen to know the answer to that one?
I'm just reading that now. New Zealand. Not so much around the apps or solutions, to be fair. Yeah, no, I'm not aware of a list around, yeah, because often, you know, private business entities, you know, they will develop their own applications on yeah, ArcGIS or any GIS platform, and there is probably some duplication across different businesses. So yeah, not too sure of a list, to be fair. There probably is a little bit of crossover, you know, when you think, I'm going to just pick out Cyclone Gabrielle here again around, you know, maybe, you know, the generation of damaged areas and slip areas. And now that there's lots of imagery coming through, there's probably lots of people looking at doing that, where, you know, ideally, once one authoritative source is available, it could be something that could be pushed out. But yeah, can't really answer that question overly well.
All right, we have one more about IoT information and use. To do in workforce tasking, industry metering, tracking vehicles, farm machinery. That's come up quite a few times, Sarah, hasn't it? In a lot of.
Yeah, I can probably, I don't know, again, not sure if I'll answer it, but definitely the push from the agriculture sector as I'm dealing with clients and potential clients is around bringing in all their data into one place, because, you know, there's lots of places, perhaps related to the other question, there are lots of places or platforms to do certain ag geospatial things, but not necessarily one that has it all together. And of course, inside the ArcGIS platform, yes, you can display, you know, the metering and tracking of vehicles, you know, if it's, you know, tractors or harvesting machines going through vineyards, where they are, you know, all that data can be streamed in, and we're starting to see that similarly in a forestry space with all the harvesting machines, getting those live not only the live or regular tracking of where those vehicles are, but any metrics from those vehicles, if it's the how full the diesel tank is, when they were last serviced, or whatever they're doing. If it's harvesting grapes, what is the volume of the grapes being harvested, and of course being able to display that on a map with all the other relevant farm, orchard, vineyard kind of data overlaid. Yeah, it's definitely heading down that track.
Yeah, I'm a little bit out of the sector as well, is that actually with a lot of IoT sensors, river gauges and water gauges, basically that's come up quite a few times. I've seen that come up. This is again where those sort of dashboards have been incredibly useful, just to monitor basically assets in real time and to see getting gauges of like hazard information, which is obviously critically important for a lot of people to know if rainfall is hitting a certain threshold that like a flood is likely. We've seen quite a few dashboards created from that as well. Then we have with the whole workforce tasking as well, one of the classic examples that we always show in demonstrations, at least in the ag sector, is sort of a spray dashboard where we can see the live feed from workers and what farm width section of their lands and parcels have been sprayed already. And again, having that sort of sensor with weather data that's live, so that can kind of influence also the tasks that need to be happening. Of course, if spray is dependent on weather, but there is systems in place that we've seen before where we've designed dashboards and integrated systems where weather, field worker, and what they have done actually out on the farm is coming in all as live data in a single place where you can see that and manage your workforce a little bit better. It looks like that is all the questions that have been asked. I think that unless I can do one last call to see if anyone else has any questions here, let me go and switch back to our slides. If no one else has any questions, just a reminder, I'll put this screen up, that if you want to shoot us an email later, maybe you can't think of anything right now, but in the future you might have some questions. Feel free to email me or Sarah or Scott Campbell as well. We didn't put his email up on here, but Scott Campbell is available at scottcampbell@eagle.co.nz to answer questions as well in regards to anything that you saw here today.
Yeah, and just I was just going to say, just to reiterate on that, there's also the GIS support team. So yeah, feel free to reach out to us at all if you are wanting to even understand some of the tools. They could be existing tools, or if you're migrating from ArcMap to ArcGIS Pro, there are far more spatial analyst tools in Pro that exist in ArcMap, even including newer slope, creating slope layers. If you're creating your own, there's more advanced tools inside ArcGIS Pro. So if you haven't migrated to Arc Pro yet, or you're on that journey, I would definitely look at that, because around spatial analyst, 3D and imagery analysis, Arc Pro has some big improvements on ArcMap. And if it's around, is there a data source for this? Is there a publicly available data, or that it might be something you're after? Please feel free to reach out to see if we know where it is, because one thing with the Garda project is there is a lot of data out there, but it's knowing where to go to get it, particularly if you're working across regional councils or regions. It's a bit easier if you're inside one area, but if you're working across multiple regions in New Zealand, it can get confusing where to go. But there is a wealth of information out there, so we're more than willing to help you kind of locate some of the information you might be after.
Great. All right. With that, I think I can tie things up here. I might turn off my camera and hang around for a few minutes, just in case somebody is writing out a long question that they just haven't been able to pop into the chat yet. But yeah, thank you guys so much for attending, and we hope to see you guys around for our next webinars coming up. Thank you so much.